Welcome everyone. We are here at the FTF 2016 in Austin, and I'm sitting in an electric cab of Austin together with Chris, and we'll be showing you now some demos around smart mobility and smart cities essentially. So this demo contains various use cases we have realized together with our partners, Coda Wireless, Siemens for the infrastructure side, of course the city of Austin, and so the first thing we're about to see is that on that screen right in front of you, I hope you can see that we get information from a traffic light. So we're right now standing in front of a red traffic light. That traffic light transmits that information to the car, so we can see it on our screen, and it tells us that we need to spend another 30 seconds until it goes green. So the idea here really is to make traffic lights more intelligent, smarten up, and get the information from all the different cars approaching the crossing. And once the traffic light gets all that information, of course, you can imagine that you can switch much more intelligently, much more optimal in order to steer traffic, and by that essentially reduce traffic jams and traffic in general, and make it able for you to reach your destination much faster in time. So the technology we're using here is called V2X. So that is essentially an automotive Wi-Fi standard. It's 802.11p, and the beauty about this technology is that you can connect cars with each other, cars with the infrastructure, like we've just seen on the red light, on the traffic light, peer-to-peer. There's no server in between, there's no cloud in between, it goes really peer-to-peer, which provides us with information with very low latency. So you, as soon as, for instance, in safety critical situations, somebody brakes in front of you, you will get that information in that very second. Imagine your car is driving autonomously, it will brake immediately. That's very relevant, for instance, for platooning use cases. So imagine truck platoons driving in a train of trucks. The first truck brakes, the very last one in that chain of truck will get that information within maximum 250 milliseconds. So there's no risk of bumping into the car in front of him. So we now get even information on the traffic light around the corner which we don't see. And that's another beauty about V2X. It sees around corners or through walls. And it's now actually green. We get the information it's green where we don't see it. Now we can also visually confirm that it's green, so our system is working here. And the traffic light or the car tells us now that we should at least drive 9 miles in order to catch that green phase. So Chris, we need to make sure that we drive fast enough so that we can cross that street. All right. So these two use cases on the traffic light, in principle, show use cases on V2I. So the communication between vehicles and the infrastructure. You could do the same with traffic lights, with traffic signs, other things on the side of the road. So there's endless use cases on communication between cars and the infrastructure. But you could have the same with, for instance, an emergency car. So imagine you're driving on a road. You have a green light a green light in front of you. You would just cross the street. But there's an emergency car coming from the right side. There's a building in front of you, so you can't look into the street. So you wouldn't know that there's an emergency car approaching, but your car will tell you and prevents potentially accidents. So right now there's another traffic light there on the side. It might be hidden by that car. So it gives us a green traffic light. That traffic light has a long-range RFID reader. So the idea is also to make pedestrians, vulnerable roadside users, we call them, could be children. We equip, for instance, a school class of children with long-range RFID tags. And once they reach such an equipped long-range RFID traffic light, the traffic light would know that these kids come along and would transmit that message over V2X to the traffic approaching the traffic light. And by that we make sure that no school kids are getting harmed and we drive cautiously. So over to the next use case. This one is on platooning actually. So we have that truck in front of us. It's our big IoT truck from NXP. And now, Chris, you might want to hit that back button. Yeah. And now the OK. So I hope you can see that on the screen in the top left corner, you see a live picture of a camera equipped on top of the truck. So the idea is here, imagine that you're driving in a platoon of trucks and you're maybe the third, fourth position of that platoon and you handed over control to the truck platoon. You will be able to see the front of the first truck and that's the picture that's currently being transmitted. 11P V2X has two channels. The first channel is being reserved for all the security relevant messages we receive. So all the messages we got from the traffic lights went over the first channel, and over the second channel we get these live pictures now. And you can see now, in a second you should see us moving in front of that truck. There we go. All right, and the very last use case is an important one. NXP is all about secure connection for a smarter world. So you don't want anybody to hack the system, right? And you just saw in the top right corner there that that was a skull logo. So there somebody pretended to be an emergency car, which in fact wasn't. So he didn't carry the unique authentication key, which is stored in every single device. So every single V2X device is carrying a unique key, and if you don't have that, you're being identified as somebody who hacked the system, and that's why it's safe and secure. All right, and I think that concludes our trip here through our live demo. So please be welcome to either participate in this live demo, or we have on the fourth floor another demo on all these use cases and different technologies we just showed to you. So thanks a lot for participating.